All right. Thanks,
If we,
Emily. Hopefully you guys can hear me okay. Okay, so yes, as Emily said, my name is Jessica Baweja. I am a social psychologist by training, so that's what I studied in graduate school. I've been here at PNNL for about 4 years, and most of the time, what I do here is I study the ways that humans interact with technology. Um, and as part of that, probably not a surprise, my job has changed a little bit in the last few years as humans are interacting more and more with large language models. What I'm going to do today is give you guys a little bit of an overview of large language models. I'll talk conceptually about how they work. Those of you who are really familiar with the technical details will have to forgive me because really what I want to do today is kind of give you a little bit more of a conceptual understanding of how these models work and how they generate text or images. And then we'll talk about some basic good practices in terms of prompt engineering and in terms of using large language models in a sort of responsible and ethical way. Um, and I'll give you a quick example of one particular usage of LLMs just to kind of whet your appetite a little bit about how valuable and how powerful these models can be in science. So with that, I will share my screen and we'll jump into the actual presentation. Okay, so um, starting out with just some key definitions here. So this is kind of the landscape of terms that we hear about in the world of artificial intelligence. So artificial intelligence, no surprise, is really the broadest term. So it's the field of computer science that's devoted to creating machines that can perform human-like tasks. So it's a really big bucket of anything that looks like, a human could do it, but instead it's a machine, right? Machine learning is what as you all talked about yesterday, and it refers to programs that can learn from data without being explicitly programmed. So just like Emily was describing, these are programs that learn patterns. Um, One particular type of machine learning that's been behind a lot of the innovations that we've seen in the last 10 years or so is something called deep learning. And deep learning is a type of machine learning that relies on artificial neural networks, and specifically on artificial neural networks that are arranged in layers of three or more. And what I'm going to spend my time on today is talking about generative AI. And generative AI is a type of AI that can create new content. So it's trained on content like text or images or music or videos. And it can use deep learning or other approaches to create more of that content. Um, and forgive me for including generative AI under the sort of bigger picture here of machine learning. Technically, there are types of generative AI that don't rely on machine learning, but for the most part, those models that you're interacting with, like ChatGPT, are based off of deep learning and machine learning approaches. So before I dive into large language models specifically, I want to kind of remind everyone of the broader landscape of machine learning and how and that'll kind of help us understand where large language models fit a little bit better. So there are broadly three types of machine learning. There's supervised learning, which is where the model is learning from labeled data. So labeled data, and it can be used then to predict new unseen data. So one example of this might be, training a model on a set of pictures that are labeled with what's in those pictures. And the model will learn the patterns within those pictures and hopefully will be able to accurately label a new unseen picture. So a model that's trained, to recognize pictures of dogs and cats should hopefully be able to then identify a new picture of a dog or a cat that it's never seen. In unsupervised approaches, the model is learning from unlabeled data. So you're not telling the model anything about what's in there. You're just discovering the patterns or the structures that exist without any guidance. And then reinforcement learning teaches models to take optimal actions to maximize a reward signal. So this is kind of reinforcing or rewarding particular behaviors by the model as it approaches a specific goal. And this is, something that you'll see in more autonomous methods like robotics, where you're trying to get, for example, something to complete a maze or to move towards a particular object or work through a game. Um, and these kinds of approaches are used in all sorts of things that we encounter in everyday life, these sorts of machine learning based approaches, right? So when we apply machine learning, it can look like a few different things. It can look like classification. So which category does this item belong to? And an example of that we might encounter in our daily life is our email spam filter. So it's sorting your emails into these predefined categories of spam or not spam. Uh, Regression is another common approach or common AI method, and that asks what numerical value can we predict. So this could be, trying to estimate the price of a house, for example, where you're trying to predict the value of that house based off of a number of factors. For example, in the location, the price of houses around it, the size of the house itself or the lot. Um, Regression and classification most often are based off of supervised learning approaches, and the last two are most often based off of unsupervised approaches. So clustering, for example, looks at what items naturally group together. So Netflix movie recommendations are a great example when you see those sort of suggestions for another movie that you might like, it's probably based off of this clustering of similar movies, and you have watched some of them but not others. So the algorithm then suggests, hey, you should watch this movie. You'll probably like it based off of what you've watched already. And then finally, dimension reduction is again commonly an unsupervised technique where we're trying to represent really complex information more simply. And all of us that use Spotify have encountered this, where it's kind of creating a genre, for example, based off of all of the kinds of music that's out there. And so these are what we see often in the world of machine learning, but those methods that we've talked about so far really focus on understanding patterns in existing data. They're really good at answering the questions that I outlined, like what category does this belong to, or how are these data points related? But there's another problem that AI can tackle, which is the creation of new content. And that's where generative AI comes in. And so just like other kinds of machine learning, generative AI is based off of training data. But unlike those other approaches, it really focuses on using the patterns within that training data to allow that model to create new content. So, for example, a model that's trained on music learns the patterns in music and can create new songs. A model trained on images or text has learned the patterns within those images or text and can therefore create that new text or that new image. And so that starts to, kind of push us into where we can start to use these models in a more creative way. Um, so um, Large language models, very broadly, can kind of be thought about like this, right? Like this picture where, they have all of this training data, whether that's text or pictures or video. I'll focus on text on this example just to kind of simplify matters. But I think conceptually you can extend the understanding to other kinds of content also. Um, but you have all of that training data and you essentially present that information to a neural network in the middle. And what happens is that the neural network then kind of learns the patterns that are inherent in human language. So it's learning how words are typically related to each other and how humans speak. And then based off of that training data, and the user's prompt, it can then create new text, right? So that text can take a lot of forms, right? It could be sort of long form paragraphs, it could be code, it could be bullet pointed lists or tables, right? So by using the vast amounts of data that they've been trained on, they are able to then produce really fluid content. So I want to spend a little bit of time kind of talking just a tiny bit more about how this happens, right? So let's imagine for a second that you're talking to a large language model and you give it this prompt, and the prompt just starts out with the future of AI is. The first thing that the model is going to do is it's going to break that prompt up into chunks. Right. So each and this process is called tokenization. And it basically means I'm going to take this prompt and put it into meaningful units that the model can then use and process. In this example, I'm using a really simple form of tokenization, which is just word-based tokenization, and that's pretty common, right? So now we've got this set of tokens that the model is processing. And essentially, what's happening under here is it's thinking about, okay, or using the patterns that it's learned, it is um, trying to understand what could come next, right? And what's shown on the right is all possible ends to this sentence, right? And you can see there, there's many, many more. And each one of those ends to this sentence is associated with a particular probability, right? So they're all valid. The sentence could be the future of AI is bright or promising or uncertain or transformative or automated, right? Every single one of those could work. Um, and so one thing that so what the model is doing is essentially looking at those probabilities and making a decision. So for this example, let's just assume that the model says, hey, I'm going to pick the word bright because that's a really high probability word. And now I'm going to then kind of append that to the end of the sentence or the end of the phrase. And then I'm going to try to figure out what should come after that, right? And after that, you could have another set of tokens, right? So that the next token in the phrase could be and, as, for, because, or it could just be a period, meaning that that's the end of the sentence, right? Um, Here, perhaps the model, picks the sort of period because that's again a fairly high probability token, right? So this is what the model is doing in a really simple form. Now, it's important to understand that there's a couple of other more complex underlying things that are happening, right? So, really in practice, there is more complex math in terms of how the model is selecting the token, right? So there are things that look at not only the probability of that single token, but also the probability of the overarching phrase, right? So just looking at what the highest likelihood next word is actually doesn't turn out to generate very good text, right? And there are a few other things that kind of go on under the hood that have some implications for how these things work. And I'm actually going to highlight the one in the middle first, right? So um, that is something called stochasticity, and stochasticity is just a fancy word for randomness. So in order to generate more sort of interesting or human-like text, one of the things that most models will do is introduce a certain degree of randomness. So it's not just going to pick the highest probability token each time, but instead it's actually going to kind of randomly choose a little bit. And you can actually alter this behavior when you design a model if you'd like. And what that means is that even if you give the exact same prompt to the exact same model, you're going to get a slightly different response each time. And that's a feature, not a bug, right? It helps the model to generate something that is a little bit more human-like and a little bit more fluid. The other thing to keep in mind is that just like I explained, these models are not relying on real-time knowledge. Now, there's some exceptions to that. Those of you who interact with ChatGPT know that there's like a little, toggle that can allow that model now to go out to the internet. And that's starting to be true for more and more large language models as they become what we call agentic, meaning that they're able to kind of do some actions. But in general, at their core, these models are relying and creating their response based off of their training data and not current information. And the last thing I'll mention is that there is a context limit, right? So I described this process of tokenization, where you're trying to, where the model is trying to take what you're putting into it and process those tokens. There is actually a limit to that. Now, with more recent models and the computing power that we have these days, this is less and less of an issue, but there is in fact a context limit. So there's only so many tokens that the model can hold within its memory, and really, really long prompts or really long conversations with the model can cause the model to quote unquote forget earlier information because it simply falls outside of that context window. And that includes when you do something like upload a document that's really long or have a bunch of code that you're working with. Uh, the model may not be able to remember earlier parts of that conversation. So couple other sort of myths that I want to dispel as we start working with these models more and more. So large language models by design, don't remember separate conversations. So every conversation that you have with them is a blank slate. And again, this is starting to shift a little bit. So for example, I'll keep using ChatGPT as an example because I know a lot of people interact with it. Many of you may have noticed recently that they updated it so that the model will remember some information about you and has a profile for you if you're signed in, which, by the way, you can toggle that behavior on and off. But by default, most of these models, when you have a conversation with them, you're starting fresh. Um, this is more of a problem for people who are using models that are hosted at like a school or an organization. So I'll show you here in a little bit. We have kind of an internal version of some of these models that we work with. But it's important to remember that LLMs don't have access to anything you haven't given them, right? They're not on your computer, they're not on your, school system. So you have to kind of keep in mind what they do and do not have access to. And then finally, when you're sharing, like, let's say I have a journal article, I'm a scientist and I'm working with that journal article and I want a large language model to summarize it, which is a task that I can ask it to do. It's important to remember that they're not like reading the document, right? They don't see documents the way that we do. What they're doing is processing the text, right? Now, many of the models are now what we call multimodal, meaning that they can interact both with text and images, but it's not seamless, right? And so you have to kind of be mindful of what kind of document am I sharing, and make sure that you're kind of checking to see what it's able to process out of that document by like asking it questions, right? What's on page 3? What does this table show? And that's going to help you to understand, the degree to which the document was able to kind of process, or the degree to which the model was able to process that document accurately. Okay, so that's kind of the crash course again, and sort of a conceptual explanation of what's happening, right? And hopefully that gives you a little bit of a better idea of like these things are not magical. They can seem really magical when you first interact with them because they're really impressive. But really, what's happening is just a lot of math, right? All the way down, it's eventually a matrix. And so keeping that in mind. One of the things that can really help us when working with large language models is getting a little bit better about how we interact with them, and that whole process is what we refer to as prompt engineering. So many of you may have seen like guides to prompt engineering or suggestions. And so just as a basic idea, the prompt engineering is just the process of creating better outputs or better inputs so that you can get more relevant, higher quality, or more useful responses out of the model. So it's just making better inputs so you get better outputs. And as I'm going to talk about a couple of principles, but first I kind of want to break down how many people kind of think about the pieces and parts of a prompt. Um, any of you who have worked with these models before will realize that spending a little bit of time crafting your inputs to them can really, really help you get much, much better outputs. You'll hear oftentimes that people will talk about working with large language models, like working with an intern or working with a student. And I think that's a good analogy, right? In that, large language models, the developers have designed them intentionally to try to be helpful to you. That's their goal, right? They want to help you. It's kind of hard baked in there. But they don't know anything, right? As we've just kind of illustrated. They know language, and they know what you give them. And so to the extent that you want to get really useful outputs out of them, you need to give them some information to work with. And so with that, let's talk a little bit about what a good prompt might look like. And I've put kind of an example here that I'll walk through. So in this example, I've just given it a simple task. I've said, I need your help writing a one-page summary highlighting PNNL's AI capabilities. And the goal is, I want people who are potential collaborators or partners in industry or potential sponsoring agencies to be able to understand, um, PNNL's AI capabilities. And I've given a little bit of an example of, or a little bit of content for it to work with. And then I gave it some guidance at the end. So breaking this down, that first bit is just the instruction, right? So it says, exactly what I'd like the model to do. It's a statement of, here's my task. The next bit here is some context, right? So it says, not just, that first sentence tells the model what I want it to do in really straightforward terms. The next gives some explanation of why I want that model to do it, right? And that could help to get output that better fits what your end goal is. That third section is what I call sort of the input, right? So this is, any information that you want the model to use to help it achieve its task. I've used a really short example here just because I wanted it to fit on a slide, but you could use a lot of information here. So one example might be, if you have a paper that you want it to summarize, you could say, I need your help summarizing this paper, and it's, for me to understand for this class. Here's the paper, right? Um, and but again, this is sort of a short and easy example. So whatever you want the model to be referencing, you kind of put it here. And then that final section is output, right? Or sort of some constraints around what you want the model to give you. And here I've been really specific, right? So I've said, I want you to give me, this one-page summary that has a compelling opening paragraph, at least 3 capability statements with examples, a statement of the impact, potential opportunities for partnership, and no more than 300 words. And then I give some, please emphasize these things, right? And the point here is that, you can get really specific about what you'd like the model to give you. If you have particular constraints, provide them. No, I'm kind of walking you through this like it's a super hard structure, and it isn't, right? You can play with this a little bit, but I think it's important to understand the different parts, so that when you're writing a prompt to a large language model, you can spend a little bit of time kind of going through it and saying, hey, is this giving the model all of these, bits and parts or not, right? Does it actually have enough information to work with? One of the things that I'll do sometimes when I'm working with a model is I'll actually write my prompt kind of separately from the model before I even hop over and try to put it in. Right. And that helps me to spend just some time to make sure that I'm actually asking it what I think I'm asking it. Otherwise, I may realize, at the end, hey, I didn't actually, put in the information it needed to get a good output here. Um, So some best practices, or at least some good practices, in terms of prompt engineering. Um, the first I've already mentioned, which is give some context, right? If you have particular guidance around, what this is intended for, what you want the model to be doing, that's going to really help, right? So in my case, I said I want this, for potential sponsors or for potential collaborators, and that kind of context can help the model to tailor its language appropriately. The more detail you give, generally the better. And Delimiters and constraints. So that's kind of that output section that I mentioned. Right. So really kind of putting some constraints around how you want it to provide that output. I want it in this template. I want it in table format. I want it to be written entirely in Python using the SciPy package. Whatever it is that you want, be specific. And delimiters are just things that kind of break your input up into parts, right? So if you have specific languages that you want it to use when writing in Python, if you have a sort of marking to say, hey, this is the article that I want you to summarize with quotation marks. That's a delimiter that says, hey, this is what I'm looking for. Um, Iterate. So one of the great things about working with a large language model is that you can go back and forth. It's a conversation, and especially as you're starting to work with them for the first time, that iteration can be really valuable, because it can help you to figure out, okay, that didn't work. Let me try again, right? And hopefully by the end of it, you've kind of gotten to where you wanted to go. Specify the audience, where do you want this language to go? Where do you want this particular kind of text to be targeted? And as much as you can, be clear, simple, and polite. Right. I used the analogy of an intern earlier. Like say, I think it's a good analogy. And now there was, I think, an article a couple of months ago now where one of the folks that works for OpenAI, which is the company that developed ChatGPT, talked about the computing costs of saying please and thank you to ChatGPT. And it's apparently non-trivial. Which is pretty funny, but I do think it is actually helpful, and there is at least some evidence to suggest that sort of being a little bit polite to the model can be helpful, right? And that's not really a surprise if you think about it. The models were trained on human language, and we all tend to behave a little bit better when we're nice, or when the person asking something of us is nice. So there's no reason to believe that large language models would be any different. Okay, so um, I want to show a quick example, just for fun, to kind of illustrate some of the things that large language models are capable of. And I'm going to use an example of actually asking a large language model to do a quick plot for me. And this is something that you'll often hear about people at PNNL doing, and out in the scientific world. One of the things that's cool is that large language models have actually gotten pretty good at coding. And when you reflect on this, I think it makes a little bit of sense. Right. So coding is something where there's a lot of really high quality training data that's available. So we have things like, Stack Overflow that exists. There's lots of documentation on packages. And so there's lots of data that's available to actually train the models. So um, there's GitHub libraries, right? So there's lots of data that the model can be that can be used to train the model on the patterns in coding. And the other thing is that coding, unlike a lot of human conversation, is highly structured. So that can actually simplify things a little bit, right? So um, uh, it's actually a really nice use case for a lot of folks to kind of leverage generative AI and leverage large language models to help them to create some code. And so I'm going to walk through an example in slides, and then I'll actually switch windows and show you what this looks like in practice. So the example that I picked here is using some public data that's out there on the internet. It's through a website called Our World in Data. And I picked the example of looking at the number of people using the internet. And so there's some public data that's out there on the number of people using the internet in 20 over time. And I picked the years of 2020 and 2021 to do a quick comparison. So sort of inherently, I'm asking the question like, were there more people who were using the internet in 2021 versus 2020? So let's say that this is my goal. I'm a scientist and I'm exploring this question. How could I do this with generative AI? So in kind of a step-by-step format, if I wanted to do this, I would kind of start out by getting the data. And generally, I tend to prepare data in CSV format. It's a nice format for working with a lot of packages. It's very simple and straightforward for a data set like this. It works really well. Um, in the prompt itself, I'll actually, and I'll show you this in just a second, I actually will include the little, like a little snippet of the data to give the model a sense of what the data look like. So I'll just, head in Python, right? So give the first 5 rows. Um, One of the things that's cool now with a lot of these models being multimodal, meaning that they can work with different modalities of data, not just text, but also pictures, or in some cases now video. You can actually paste in a picture of what you want. Right, so you can put in an example figure, and I put a couple of links to some places where you can get examples of different graphs. I'm using Python here, as the example. Obviously, if you're using a different language, you would need to look somewhere else. But you can say, hey, I want my plot to look like this. And if you have any other kinds of desired packages or details, you can kind of put that into your prompt also, right? So think about if you have a design change that you want to the picture. I see the model, I see my example figure made the water white. I want the water to be blue, whatever. Um, you can obviously specify particular packages. You can also do things like specify code style guidance, right? So if you have a style guide that you want it to use. And so putting some of the good practices that I have already talked about into place. Here is kind of a prompt or what a prompt might look like for comparing internet usage. And so in the model I'm going to use here is Claude 3.7 Sonnet. This is a model that comes out of Anthropic. It tends to be reasonably good at coding. There's some variability between models in terms of performance on coding tasks. Sorry. And so that's the one that I picked here. And so the first line of that prompt is just the instruction where I say, hey, I'd like to use the data available from our world in data to plot the share of the population using the internet in 2020 versus 2021. The data can be imported using this code. And that code, by the way, I'll show you here in a minute, comes from the Our World in Data website. So they actually have a nice little example of here's how you can import code in Python. Those of you who are familiar with Python will see pandas and things like that. And then, as I mentioned, I think it's really helpful to provide a snippet of the data, and that's because if you're going to be using it to do data analysis, this will help the model do things like use the right structure, use the right column headers, things like that. And then the last piece here is, and so that's sort of the content that I'm asking the model to use. And the last piece here is my restrictions around output. So I said, can you write all of the code to show the average percentage of the population using the internet in 2020 and 2021 by country using CartoPy? I want the resulting plot to look like this image, and I'll actually paste in an example image, but I want 2021 on the right and 2020 on the left. So I actually pasted this prompt into my window, and Claude helpfully then sent out this code. So it actually just generated all of this. And when I ran this code, this is what I get, right? So it actually then produces that. And so bear with me here for a second, because I'm going to do the dangerous thing, and switch windows, and give you guys a kind of a quick run through of what this actually looks like. Okay, so we'll just hop on over here, to this screen. So this is a little bit of movie magic here, because I did all of this in advance just to give you guys kind of a little bit of a smoother experience here. But that's not what I want. So this is, this is just kind of an internal way that folks at PNNL will access some different models. So, as I said, I'm using Claude 3.7 Sonnet here. And so this is the prompt that I showed you on that slide. And one of the things you'll notice is that, kind of messes up the formatting. And so it doesn't look exactly like what I had earlier, but that's okay. We're not gonna worry about that too much. And actually, I'm going to go ahead and paste in. So this is the example figure that I'd like it to use. And it actually comes here from, the Our World in Data website. So I just copied it. I just downloaded a copy of this, little figure here. And that allowed me to kind of say, hey, I want I want the resulting plot to look like this. And so, this is what that prompt ends up looking like when I actually put it into Claude. I'm going to go ahead and click send. Now, those of you who are familiar with large language models will know that Claude 3.7 is what we call a quote unquote reasoning model. And all that means is that it's been reinforced. So I talked about reinforcement learning earlier, to spend a little bit more time thinking step by step, and to try to um, actually kind of think through a problem before responding. And so you'll see it took just a second for that model to provide me an answer, and that's because it was kind of thinking through what needed to happen, right? And so it's kind of cool here because then, what I get out of this is the actual code, right? So it's spitting it out in this sort of nice looking, happily color-coded format, and then it's giving me an explanation of what it's doing, right? And this is another kind of thing that those quote-unquote reasoning models will do, which is try to explain its reasoning as it goes. So I find those kinds of models to be really helpful for doing tasks like coding, because they give you a little bit more kind of understanding of what's happening. Um, Now, I'm not going to copy and paste this directly, because there's some variability in what it generates, and any of you who've used large language models for coding tasks will know that the code that these models produce is not always completely error-free. Sometimes there's a bug or two that needs to get worked out, and so for the purposes of illustration, I'll just show you. I stuck this into a Jupyter notebook. If it's not identical, it's pretty darn similar. And so if I actually just go ahead and run this, it'll take a second. But what it will eventually do here is actually produce the plot that I was just showing. And the reason that I wanted to share this example is because I think it's a fairly simple, constrained example of how these models can be super useful for scientific tasks. And there's our plot. So it looks like the one that I showed you on the slide. So you guys know that I'm not lying to you. Um, but this is kind of a realistic example of a question that one might actually ask uh, of some data sets in a scientific application. And I did it with very little familiarity with the data, right? So, I didn't necessarily, I wasn't super familiar with this. I haven't worked with these data before. And so I think it's a nice example of how we can kind of get kind of use these models as a little bit of a force multiplier, right? It takes our brain and makes it even better, right? In some ways. But I want to highlight something at the bottom here, which is that in addition to producing the plot, I also did a couple of summary statistics, or the model did, right? And I think that's really useful. And that's really useful because it helps us to do something that's really, really important when working with these models, which is validate the things that we are seeing. So one of the things that is really, really critical if you're using these models for coding tasks or for writing or even just for general question answering um, is to make sure that what the model is giving you is right. Um, and one of the ways that you can do that on a data set like this is actually ask it for things like summary statistics, right? So what it's telling me here at the bottom is, oh, there's 193 countries with data in 2020 and 191 with data in 2021. And it also gives me the average internet usage. Now, these are really straightforward statistics that I can easily verify myself looking in the data, right? And that means that I am very capable of figuring out whether or not what this plot is producing actually reflects the information that's in the data set itself. And that's a critical component of making sure that we're actually using models in a responsible way, particularly when we're talking about using them in science. So it's really easy for me to just take and copy and paste the code and run it, and that's really cool. Right. But it doesn't absolve me of my responsibility as a researcher and as a scientist to make sure that I actually understand what it's put out there. And so that's the last thing that I want to kind of talk about here um, before we take some time for some questions, which is using these models responsibly. So what I just mentioned, I think, is a really good example of, why it's important for us to kind of verify all of the content that we're getting out for accuracy, right? This is a silly example that I'm using to, kind of show you guys some capabilities, but this has really serious implications when we start thinking about science as a field, right? As an approach to understanding the world. Um, and so it's important when we work with these models to recognize that we are still responsible for verifying that content for accuracy. One mistake might not matter, but those mistakes do build, and they can have really serious consequences when we start applying these technologies across science as a whole, right? So whenever you use a large language model, it's really critical to validate the results. And you also have to make sure that you're following any rules around how you're using that AI model. So again, I'm going to focus on using AI in science. There are particular rules around how we are allowed um, to use AI in science, particularly if we want to publish something in a scientific journal and put it through the peer review process. So there are some publishers that do not allow authors to use generative AI in their writing at all. So they simply prohibit the use. Some allow it, but they require that authors disclose that they have used generative AI and make a statement that they used AI in the creation of the content. And so I put an example of what that might look like here at the bottom, right? So um, and you can think about this in some ways like you're acknowledging the contributions of another author, right? And that you want to explain what the model did, how it was used, and but ultimately how that content was validated and verified by the humans involved. So in this example, I specified, hey, I'm using the AI incubator, which is our internal way of accessing a bunch of different models from Anthropic and from OpenAI, and Perplexity, which is another publicly available model. And these tools were used in this way, to create these things. But I, reviewed and edited and approved all of the content, right? Um, so the image there on the right is an example. This paper has obviously been retracted, but it's an example of a paper that was actually very briefly published in 2024. And those of you with really good eyes may be able to read it, but for the rest of you in the back, you'll see that there is under the introduction begins with certainly here is a possible introduction to your topic. Um, and those of you who have worked with ChatGPT will recognize that that is how ChatGPT will often begin its introductions or its responses, right? So it's pretty clear from that statement that these authors used ChatGPT to produce the content for their introduction, and in fact, they actually completely failed to remove that sort of leading statement. Um, and not only is that kind of not a great look for the authors and the journal, I think it's a general kind of indication that hey, we have to be really careful and really mindful of how we're using these materials. Obviously, in this case, I think the peer review and the editing failed here too. In good science, all of this should have been stopped. Prior to it actually reaching public eyes. But I think it's a really good example of how these things can be misused if people aren't stepping in and actually taking ownership of the content that's being generated and making sure that it's right, and that they are responsible for the information that's being shared. Um, as we start using these models more and more within the scientific field in general, there have been a lot of questions to which we don't yet have great answers about the impact that they might have on scientific quality in general. Right. So, one of the big things that we often talk about in science, because I think it's an ongoing challenge, whether we're using large language models or not, is the problem of reproducibility. Um, this has been like I say, a challenge in science in general. If experiments aren't well documented, or the details of the studies aren't disclosed carefully, we often have difficulty reproducing published results. And that gets even more challenging when we start bringing in large language models, where as I mentioned, they have some degree of stochasticity in their responses, some degree of randomness. It may be difficult for others to kind of take what you've done and reproduce it when you've leveraged a large language model. One way to deal with that challenge is to think about including interactions with the model, things like prompts, outputs, and dates as supplementary material to published work, right? So using that as part of your broader documentation of your study. I used this model, I used it in this way, and here's the prompts, and here's what the model gave me. Transparency is another critical component of, I think, being a sort of honest about our use of generative AI, right? So that example that I gave on the last slide is one way that we can kind of disclose generative AI usage. And I think that promotes its acceptance as a scientific tool, and it acknowledges its contributions, right? And this is kind of broadly part of intellectual honesty, right? We all talk about intellectual honesty as scientists, as students. And it remains important as we start working with large language models in more of a human machine team, right? Where it's us and the model together, right? Where we just need to acknowledge that these are a thing that we are using, and acknowledge when our work has been accomplished, at least in part, in collaboration with that model. And the last sort of, I think, impact or question that we have right now is generally about the impact of large language models on scientific quality and overall authenticity. There is absolutely no doubt that there has been a rapid surge of use in large language models in terms of, writing assistants, coding assistants, and there are questions that we have about whether or not that actually improves the quality of science. And what I will say, I mean, humanity has sort of always taken the, we'll mess with it and find out approach towards technology, and that's the approach that we're taking here. But I do think it's a real concern and one that should be taken seriously as we consider, how and whether we want to leverage these models in our work, right? And to do so again very carefully. The question of authenticity, I think, is is you'll often hear about it, or you'll more often hear about it in creative fields, where people are doing writing for creative purposes, or creating visual art. Um, and but I think it also applies within the field of science. I remember reading as a student, and I still have this experience today as a scientist, reading people whose voices I recognize in the scientific field where I work, right? That were impactful to me as a researcher and helped kind of form my understanding of the world. And there is concern that as we start to use these models more and more as writing assistants, that we may lose some of that authenticity in the field. One way of managing that is to give models a sample of your own writing to make what its output sound a little bit more like you. Right, so that you don't completely lose your own voice as a researcher and a writer as you start to use these models as a tool in your own work. So a couple of, I guess, reminders as we start kind of moving into using LLMs more and more, right? So these are a couple of silly examples, um, but I think they're good to keep in mind. Again, models don't necessarily have access to the internet, or at least they don't necessarily have access to the internet. By default, their knowledge cutoff is going to be based off of their training data, right? So they're basing their response on their training data. They only know up until the date that that training data ends. And unfortunately, there's no standard cutoff for that. It's just whenever the developers last released that model. So that's information you kind of have to look up. And there's no kind of easy button there. Most models will have that information baked in, but you can always look it up. But if you ask it a question about recent events, it may or may not know based off of the data when it was last trained. And if I ask it a question like, "Can you tell me the latest news?" its response is, "I don't have the ability to do that," right? And you should probably, go to these websites that have news that you can use that do have access to recent information. It's also, not perfect in terms of its logic, right? So this response is actually better than the one I got previously. So um, in an example of trying to prompt the model to think logically, I gave it an example of running, right? So I started training to run a faster mile in January. I started out at a 10-minute mile. It's now April, and every month so far, I've shaved a minute off my time. How fast will I be running a mile in September? Please make your answer brief. And the model here was GPT-4o, and it responded, if you can continue improving at the same rate, you'll be running a 4-minute mile by September. Anybody who has been following Faith Kipchoge's model, a world record attempt. Women are not yet running 4-minute miles, sadly. That's not a very likely response, right? When I tried this example previously with one of the GPT models, it actually told me I would be running a 1-minute mile, which is obviously impossible for any human. Um, and so it's a great example of how these models don't always extrapolate well from data, right? And they aren't always going to give you a super logical response. Again, this is why it's really critical when we ask it questions that we understand how we can validate that response. Um, so um, the other thing that I want to highlight is this idea of hallucinations. And a hallucination is just a fancy way of saying the model produces false, but seemingly accurate information, right? It's fluid, it's plausible, but it's actually wrong. And so I gave a question to one of the models here at this was Claude 3.7 sonnet, and I asked it, hey, what are some papers that discuss the feasibility of nuclear fusion? And as we think about how the model is responding to this, I wanna kind of revisit what I mentioned earlier, which is, think about these as like a statistical word generator, right? That has no access to the internet. So when you think about it that way, how would you think that the model would respond to this question? I've asked it to give me papers, But what it's going to do is it's going to produce titles that sound like papers that it's encountered in the past, right? On the topic of nuclear fusion. Now, those responses may or may not be real. They just sound, and statistically probably could be titles of papers that talk about the feasibility of nuclear fusion. And so the model here gave me 5 different responses. I won't read the titles because they're really long. And I went and then I took those titles and I popped them over into Google and I checked to see whether or not any of them exist. And so I showed here on the right, um, that out of the 5 responses that it gave me, 3 of them are not real, so they don't exist. And actually, 2 of them were, which is probably more of a sign that those papers have had a very large impact on that particular topic area. Um, but what I want to highlight here is, again, there is no reason to think, without access to the internet and relying only on its training data, that the model would produce an accurate response here. And this is a much better use case for a model that does have access to the internet. And I'll mention, some of you may be familiar with it. This isn't a plug, but Perplexity is a good example of a tool that is much better for answering a question like this. ChatGPT has its own sort of research tool now that you can use, that does have access to the internet and can look at scholarly articles. But if you ask models questions like this, where you're asking them to cite their sources, that is almost always going to result in a hallucination, a plausible sounding but incorrect response, because again, they're looking at training data. They don't know what is and isn't real. And as we start applying these tools in science, I think that's a really, really important thing to remember. Um, so a couple of takeaways, and then I'll be happy to answer any of the questions that you guys have. I think first, I mean, there's no question that these models can help us be more and more efficient, right? They can produce text incredibly fast. They can produce code incredibly fast. They can, help us with all sorts of tasks. And save us a lot of time, right? One of the most common things that I'll hear about is people using these models for summarizing things, for helping to rephrase an email that you're struggling with, to create meeting notes or meeting agendas, right? So they are very effective at a lot of everyday tasks that we use, that we currently can spend a lot of time on. The other thing that I'll kind of highlight as a takeaway, is that being more specific in your prompt, being clear, being detailed, is going to give you much, much better results. The more context that you can give a model, the better off you're going to be. And if I leave you with one thing today, hopefully it's the importance of verifying, um, validating the models that you're, the output from the models that you're using, right? Nothing about using a large language model absolves us from our responsibility to be good scientists, to be good citizens, and to make sure that we're putting out good information into the world. And so as you're working with these models, take the time to make sure that what you're getting out of it is correct. There's a few different resources. Not all of, these have, a lot of these have some free and some kind of premium or paid responses that can help you kind of learn a little bit more about working with generative AI. The first is IBM Skills Build. They actually have a particular section devoted towards students and talking about working with generative AI. DataCamp has a ton of modules on AI in general, and kind of walks you through a whole introduction. There's some resources available on Coursera. And then obviously this boot camp that you all are going through right now, I think is a great sort of introduction to working with machine learning and artificial intelligence in general. So that is what I have for you all today. I'm going to stop sharing my screen. And again, I'm happy to answer any questions that you all have.
Thank you so much, Jessica, for that awesome overview and information on the power and some of the limitations and things to be aware of. So let's thank Jessica. And we'll open it up for any questions in the room. Anyone asking, ask with the mic so everyone can hear online.
Thank you for the talk. Nice presentation. This is still confusing for me. Who is or are the authors of the new text or data that is generated? If the AI is the one that generated data, but we are providing data that probably all belongs to someone else, and we guide them, so how can we refer to the new data that is generated? That is my first question.
So that's a really good question, right? So if I've asked the model to generate an article or some text, then I'm going to use it in an article. Is it the AI's, or is it mine? I'm going to give you probably an unsatisfying answer to that question, unfortunately. So I think there's an ethical answer to that, and then maybe a sort of authenticity answer to that, and then there's sort of a legal answer to that. Now, I'll just say on the legal side, we don't know yet, right? So, there are a lot of cases right now going through the courts, in the U.S. and internationally about what can be copyrighted, whether or not training large language models on copyrighted content is considered fair use, and so on and so forth. And all of that stuff is going to be making its way through the courts probably for the next few years. And so from a legal perspective, I don't think we know yet who technically owns or is responsible for, or I shouldn't say responsible, but who technically owns and gets the copyright for or gets the intellectual property rights for content generated out of a large language model. I agree with you that it's not a black and white question, and that I worked with the model to do something, right? And yes, the model provided a response on training data, and maybe some of that training data was actually copyrighted. We don't know because most of these companies don't tell us how they're trained. But it's not as simple as the model owns the content, or the developer of the model owns the content, or I own the content, right? It's probably somewhere in the middle, right? And so we don't yet know yet. I think from a legal perspective. Now, from an authenticity perspective, I think this is to some extent a judgment call, right? So I think one of the things that we have to do as scientists, or as people working with large language models, is kind of make a determination about the level of sort of involvement that we want the AI to have, right? So thinking about it as a writing assistant. I think it's probably okay for me to, take my language and use a large language model to help me craft it, or even to use it as a brainstorming tool and create initial drafts, right? I find that to be, from my perspective, intellectually honest to say, at the end of the day, that's still my work, right? It took my words, it polished them up, or it helped me to start my writing process. That is very different from me writing a prompt to a large language model, copying and pasting what it gave me whole hog, and putting my name on it, right? And in that case, I think it would be perhaps less intellectually honest for me as a researcher to say, I own this, this is mine. When in reality, I really just prompted a large language model and took that content and put no effort whatsoever into editing it, or making it sound like mine, or really thinking about it. The only effort I put in was the prompt. And so my point here is that there is a spectrum of AI assistants, and I think there are some parts, some things that are intellectually acceptable and intellectually okay, and there are some things that probably aren't. And I think we have to use our good judgment as researchers, be transparent about the ways that we're using models, and be kind of and disclose how we're using them as tools, and acknowledge that yes, in many cases, what has come out of that interaction with the model is some combination of something that I did and something that the model did.
Okay, thank you. The second question is, so since as a company that we wanted to develop LLM, so we need the data for training. So probably we make agreement with some other companies to get data. How do we keep the data updated? Because if data is out of date, so probably we are going to get ground data. Of if new data is generated, do we assign a specific or higher weight to that data that is new to be a better probability to be a next word in when generating the answers?
So getting good training data, I would say, is kind of outside of my knowledge. So I don't have a great answer for that. What I will say is that, for training these large language models, you need an incredible amount of data, and doing this is incredibly expensive from a computational perspective. And that's why you don't see that many people doing it. So when we talk about the models like the frontier models today that are being developed, out of OpenAI and Anthropic and Google, these models are billions and billions of parameters and have been trained on so many, so much data. Right. So this is not a small undertaking. And so I can't speak to how OpenAI or Google or whoever, kind of manages that training process. Right. But we're talking about a process that essentially requires an incredible amount of capital to do effectively, and so I would imagine that they have entire teams of people devoted to figuring that question out. How do I get good training data, keep it updated, and make sure that what I'm getting out of this model, in fact, reflects up to date information, and how can that model be designed to sort of, continually learn and be released at regular intervals, to keep it as up to date as possible.
Thank you.
Yeah, thank you. Using the large language model, is there the limit of size of inputs that one can provide as a prompt?
Yes, there are. So that's what I talked about in terms of context limits. And so there are different context limits. They keep going up, and I can't quote them off the top of my head. You can, Google it and find it out. So there are, what you'll see for each model that's out there, is that it has a context limit. It's typically based off of number of tokens. Again, most often number of tokens is, you can think about it roughly as being number of words. But again, it's going to vary from model to model what that window is. And every time they release a new model, the window goes up. I will say for most people, in most applications, the context window generally isn't a problem. Where it becomes a problem is when you start working with very long inputs, whether that's, again, a large, sort of body of code that you want it to work with, where you're copying and pasting the code each time, or you want it to summarize a really long document. And there are ways around that. And I don't know what you all are talking about later today, but for coding, for instance, there are now agentic models like Klein or something like that that you can work with, where you don't have to do things like copy and paste each time. And or IDE integrated editors. There are ways around kind of the context limit for like really long articles and things like that, where you can think about, what actual content do I need here. But there are limits. They just vary from model to model. You have to look them up, and they're constantly changing.
Thank you.
Hi. I have a question about the data sets they use to train these kind of LLMs. What data sets they use? Like, is this a conversation between people, text document between doctor and patient? And if so, if that's the data, like that's where I'm thinking. If so, like, doesn't it would be helpful to the conversation between an agent and the AI can also be used to train that kind of model?
Yeah, so I mean, first of all, I'll just say in many cases we don't know. So I'm going to pick on OpenAI again. I mean, they've said to some degree what they've trained their model on, but they haven't given us a ton of transparency around that. So we don't, in some ways, we don't know, right? So it's likely been trained on, a combination of the internet, books, articles and journals, conversations on public forums, code repositories on GitHub, Common Crawl, a bunch of other things, right? So all of that's happened throughout its life cycle where it's being trained on whatever data they can get, right? But conversations with ChatGPT are also used for training. So when you talk to ChatGPT, that discussion, that you're having back and forth with the model is used as part of its training. So it will take whatever discussion you're having and kind of put that into the training data set. And that's typical for all of the publicly available large language models, so Claude or any of the others, Bing Chat. They're using the data that you're providing, the conversation that you're having, to continue to train that model.
Any other questions in the room?
I have a sort of very general question. So in terms of the logical thinking, and as you showed us, like sometimes it can fail kind of drastically. So I think people definitely want like a more logical, coherent output from ChatGPT. Do you think like LLM can be optimized for that, or do you think because it's like limits of the model it's intrinsically not fitting for that task? Thank you.
So great question. And that's actually what I alluded to when I was talking about reasoning models. So yes, and in fact, that's actually what we've been doing in the last few years. So essentially what we've done with reasoning models in particular, and this is like a new class of large language model or a different class of large language model, is we've combined the supervised learning process in terms of language with reinforcement learning, and that reinforcement learning is intended to do things like reinforce the use of logic, right? So and to reinforce thinking, quote unquote, step by step. And so that is actually one of the things that data scientists are working on right now, is trying to design these models to think a little bit more like a person, and to get them to kind of be able to better extrapolate from data. So I mentioned when I gave my silly example of running times, that when I asked that model previously what my running time would be, it suggested that it would be 1 minute. Right. This is the same model, but what's happened in the intervening time is that these models have gotten better. They've gotten better and more logical in their responses. So at some point, the model has learned, hey, that's not no human runs a 1 minute mile. I'm not going to respond to that. And so it gave me a better answer. And we're starting to do better and better at getting these models to think logically, think step by step, and sort of start to approximate what we would call human cognition in terms of how they provide responses. And they really are getting much, much, much better.
Anything else in the room, or is there anything on Zoom?
So I know there have been a bunch of questions in Zoom and then on Discord, and so I think we have a couple of minutes if you want me to go through those.
I can read one from online for you.
Sure, that'd be
So
great.
this person they ask, if I'm building an AI that does image recognition for categorizing dogs and cats, for example, how can I make sure that the user doesn't input an image of a fish or something else?
Yeah, it's a really good question. So there are a lot of publicly available data sets that you can use for training things like image classifiers, and this is true for a lot of different common machine learning tasks to help deal with that problem of like getting high quality training data with accurate labels, right? So there are I'm blanking on the name right now, and I'll think of it later and I'll pop it into the chat. But But there are lots and lots of like publicly available training data sets out there that you can use to help you kind of get that information out there. But one thing I want to highlight is that you have to still be a little bit careful when thinking about even a task as simple as image classification. And so I'm going to pick an example that I've used before, and so I'll just have you guys imagine it. I can pull up the picture, but for the purposes of time, let's imagine that we have a picture of a woman on a blue background standing, and she's wearing scrubs, the clothes that you typically wear in a medical facility. And I ask somebody to label that data to tell me what's in that picture. Now, you know, obviously one label for that would just be woman, but if we're trying to get more specific, you know, if you're trying, you know, we see that person is wearing scrubs, we could choose to label them by their profession, right? And in this generic example, that person could be labeled as a doctor or as a nurse. There's no indication from the context. She's just standing in front of a blue background wearing scrubs, whether or not she's a doctor or a nurse. Now, certainly gender stereotypes would suggest that, you know, we would probably label that as a nurse, right? But that would actually kind of reflect some inherent bias that already exists in society. Right. So it's something to keep in mind as we think about training models in general, that we need to be very, very critical of the training data that we're using, and think about, you know, whether the models actually are being trained on data that reflect the information that we really want it to learn.
More from online here. Let's see. So I think there's a few questions that are along this sort of vein of thinking, and it goes back to how the LLMs are being trained as additional conversations with LLMs take place. So if someone is having a conversation, for instance, about their research with an LLM, and then that LLM is being retrained from that previous conversation, doesn't that mean that if someone else starts asking similar questions about research, then they may get back some information from that first conversation?
So it's a good question. I'll clarify a couple of things. So first, you know, when I say that the model is being trained, in most cases, this isn't like an ongoing or continual process. It's sort of more periodic or iterative, right? So, you know, let's say, you know, we have a whole body of conversations that happen with ChatGPT, you know, in the month of, you know, July 2025. That doesn't mean that tomorrow when I talk, or next month when I talk to ChatGPT, it's necessarily going to have all of that information right away. But the, you know, the conversations that you're having are going to be ingested into the larger training data set for ChatGPT, and on the next release are going to be part of the information on which that model is trained, right? So it's not an immediate impact. So that's one piece of it. And I feel like there was another piece that I was going to mention, but I think that's probably the most critical component is, you know, that yeah, this does happen, but it happens kind of on this periodic date, the periodic kind of approach where you know, it each new release.